Hi everybody, welcome to SQL Bits. My name is Hasan Savran and I am here to speak about SQL Server's new features for developers. I have a lot to cover here and thank you for joining me today. I'm just going to jump into presentation and I'm hoping everybody's going to learn something new today. Alright, let me speak about myself a little bit first. I am a Microsoft Data Platform MVP from United States. Currently I live in Cleveland, Ohio, and I am a business intelligence architect at one of the big companies here, big insurance companies here. I have been doing web development 15 years, and my last 7 years I have been in a business intelligence team. I have bunch of accounts on social media. I'm pretty active and I like to share what I know and what I learn in any of those platforms, and in my blog I try to write at least once a week, and I like to speak, so I talk in many SQL Saturdays and code camps and any kind of conferences. And yeah, that's all about me. Let's actually look at what we are going to talk about today. So here's our agenda, and we are going to start to speak about the graph database tables. Then we are going to move into JSON objects in SQL Server, and we are going to check out how the temporal table works, memory optimized tables, and I'm going to show you how to run machine learning scripts in SQL Server, and we will end the presentation with the cluster column store indexes. So we have a lot to cover. Let's start with the graph database tables. Graph database tables are introduced in SQL Server 2017. To understand them better, we kind of need to, step back and try to understand what they are trying to solve. So before I go in details, let's actually talk about what's really happening and why we might need them. We live in a connected world, and in this connected world, things change quickly. When things change quickly, usually in business, your data changes. And when your data changes, well, your data model might need to change. You might need to add more tables. You might need to add more relations to your current data models. It sounds easy, but that can be a challenge in a relational database. Mostly because, in relational database, first of all, you have the problem in front of you, and you look at the problem and you create a data model. Usually it works great. But when you try to come back and try to, adjust this data model later, it can be a challenge if you haven't created it in a flexible way. So creating flexible data models is very important, especially in this world when everything changes quickly. And that can be a challenge in a relational database tables. Also in relational database tables, the many-to-many relations can be a challenge. You cannot have two tables and you cannot just create many-to-many joins between those two tables. You need a whole different table, usually called junction table, which means it's going to keep all the primary keys and foreign keys, and in that way you're going to be able to actually make many-to-many relations between those two tables. At the end you end up with three tables. That means you have more joins. More joins means usually slower queries. So graph database tables has some solutions for that. I'm going to cover all those in this here. So before we go in details, let's actually try to see who is using those graph database tables. So the first example I'm going to give you is, suggestion engines is the first one. So you might say okay, what is suggestion engines? Well, I can give you the best example is the Amazon, right? You go to Amazon, a product page, and usually you have the information about the product, you have the price, you have some descriptions, and when you scroll down, you see more information from the brand, from the reviews, and when you start to scroll down, things getting a little bit more interesting. Amazon starts to give you some suggestions. For example, it might say that, people who's buying this product also buying those products. For example, we have this one, right? If you are looking for learn Kubernetes, guess what? People looks like buying some whiskey with it. It's just a joke, but Amazon does this. And if you think about it, and if you are using the SQL Server to do this, this can be really a challenge. I cannot imagine the query which is going to actually give me that result in a normalized database. I don't even think that SQL Server can do that, because all data you are going to have, or all the time you're going to have to render this page, usually what is acceptable is less than 3 or 4 seconds. That means you have to get all that data in that product page in 1 second, including all those suggestions. So graph database tables gives us really good ways to do that. The second one I'm going to give you an example here is government. Government agencies, usually, what do? They track people, right? So let's say, for example, a police station, they have your ID and they type the ID, then, they have access to all the agencies of the government. So all of the information comes to the page. And when it comes to the page, they don't want to see the same data again and again and again, right? Because your date of birth probably the same in each agencies. So what they want to see is they want to see your name, then all the information under that. They don't care what agency is coming from. So it's almost like a master data management system. So graph database tables are a great solution for that. Third one is social media. And social media has been using the graph tables for a long time. And the best example I can give you is Facebook. So if you really think about it, Facebook, what do you do in Facebook? Well, you like something. As a user, you are an entity, and you go and click like. It might be a picture, it can be a video, it can be a store, it can be anything. You have two entities, one is the user, the other one is something else, and the relation is always same, it's like. So graph database tables is pretty good with that. And as you might guess, graph database tables are not new. They are new to SQL Server, but they have been out there for some time. And as I said, many people have been using that already. So let's try to figure out, I guess, how graph tables does that. So to understand them, I guess we have two different types of graph database tables. The first one is node tables. Node tables are out there to keep entity informations. What is entity? For example, a person is an entity, user is an entity, order is an entity, product is an entity. So each node tables has a column named node ID. Node ID is the identity of an entity. So if you are keeping the users, that is the identity of each user. You cannot update node ID, you cannot delete anything, and it's populated itself. So it's always there. You cannot change it. It is very important to actually, whenever you create a node table, you should create an index on it, because the system is using it internally to find data. Probably you will have no business in whenever you are writing a select statement for node IDs, but it's important to know that they are there. And if you actually write a select all from a node table, you will see that node ID comes up as a JSON object. Just like in other tables, node tables can have any type of columns. So they are just like a regular table. You can create all kind of data types on it, and they are graph tables. Second one is edge tables. And edge tables are a little bit interesting here. Edge tables are here only for relations. They keep relation information. Just like the node tables, they have an identity column named edge ID. and age ID is just the identity of each relation you put in this age table. Rather than age ID, we have two more special columns here named from ID and to ID. Those are actually keeping the relations between the entities. So if we will give an example, let's say we have a users table. And in our users table, we have two users named Alec and Anna. And let's say we have an age table named like. So what we are trying to do here is we are going to say Alec likes Anna. To do that, we are going to go get the node ID of Alec first. Then we are going to go get Anna's node ID. Then we are going to put Alec's node ID into from ID, and we are going to put Anna's node ID to the to ID. That is going to create a relation between two entities, and it's going to really say that Alec likes Anna. Just like node tables, age tables can have any type of columns. That is very important because that means that you can have all kind of metadata about the relations. So whenever you create these relations between Alec and Anna, you can actually add more columns on this table. You can say maybe when you create this relation, how they were feeling about that relation, or any type of data you want to add, it will be in there. Relations cannot be updated. What does that mean? So that means, okay, we have a table named like, and Alec likes Anna, right? What can you update here? There's not that much to update about the relation. So if something changes in that relation, you have to actually drop that and insert a new one. Directions are important. So what does that really mean is, in our example, we created a relation between Alec and Anna, and we say that Alec likes Anna. That does not mean that Anna likes Alec back. That is important, especially when you are querying the database. In graph database tables, the directions are going to be important, which I'm going to cover that in a little bit. So on the top here, as you can see, we have node tables and we have age tables. So if you think about, for example, Amazon, we go to a product page and Amazon shows you, okay, you like this product, but we have some other products like this one. So if you want to do that, you can create a product table. And you can put the Kindle Fire, iPad, and Samsung Galaxy. Let's say those are our products. And you can create a like age tables, and you can make the relations between that. So when a user actually goes to Kindle Fire page, you will easily find what other products we have like Kindle Fire. So you will be easily find iPad and Samsung Galaxy and show them in the bottom of the page, just like Amazon, by using the graph database tables. To find data in graph database tables, you need to use the match clause. Match clause is going to be in the where clause, and it takes the graph search pattern. So what is this graph search pattern? It really specifies where the pattern to search. The pattern needs to go from one entity to other entity by using at least one relation. We are going to use the arrow. It can go to left side or right side to specify which direction we are going. And also we are going to use the parentheses, remarks the relationships tables, which means like we are going to use some aliases, right? So let's say we have two products and one relation, and that we are going to end up with three aliases. So parentheses is going to actually specify which one is for relation, because it can get really complex. Here's an example. So in this example, we have products table, we have users table, and we have wish table. As you might guess, in this class, we are looking for user ID 1's wish list, which is we are starting from the user, we are going to the products table, and we are using the wished relation between them. As you can see, direction is going this way. And we only care about user ID 1. So this is going to give me user ID 1's wish list. Now, let's see some demo about graph database tables. Let's jump to Management Studio here. All right, so what I'm gonna do here is first I'm going to create some tables. How do we create those tables? Right. So now, as you can see here, I have a users table. I'm creating a users table here, and by just adding the as node at the end, this table becomes a node table. And let's run this first here. And in this users table, I have only user ID and name. So the second one is products table. As you can see, I have all the data types here, and by just adding the as node, I am actually making this table a node table. All right, let's run this one too before we continue. And what else do we have here is a alike product. As you might guess, this is an edge table. As you can see at the end, I'm just saying this as edge. And also I'm adding a cluster index here in my from IDs and to IDs. So system is gonna use those IDs, and it's important to add them, in my index. So let's do that. Also, I have a wish table. As you can see in the wish table, I have a column here. You can add any columns you like, and I'm just making this a edge table too. And also I'm throwing an index on it. Now, I have my tables. Let's insert some data in these tables. So as you can see, I am just using the same old friend insert statement here to actually add products. Nothing is really special here, but it's just regular insert statement. And let's do that first. Then I am gonna need some users. I add some users. Then, well, let's look at what my products table looks like. If you look at the products table, I have my node ID, and as you can see, there's a JSON object on it. So now I need some relations. So I have my alike product. As I said before, we need the node IDs from other entities, and I'm getting product ID 1 and 2's node ID and creating alike product here. Also, I'm passing the get date because this table I add the created date. So this is the date that I created. So I'm gonna do the same thing again and again here for the products table, and let's run this one too here. All right, now I need some wish list because I have a wish table. So as you can see in this relation table, we use the same entity, but that is not a requirement. As you can see, you can use any node IDs from different entities. So I have a user table, I have a product table. So I'm creating some wish list between users and products. Now let's run that. I have my tables, I have my data. Now I can actually go and try to find some data by using the match. Now, the first query here is pretty simple. I am looking my products table, and I'm looking my alike product. So if we are in Amazon page again and we are scrolling down, Amazon is trying to show us what other products I have, like this product. To do that, I am starting from my product table. I am going to my other product table, and I am using the alike product. Also, this is the product ID, so this is gonna give me what other products I have, like product ID 1. Let's run that, and looks like my user is looking at Kindle Fire 7. It's $49, but we can suggest him that actually, guess what? We have Fire 8 HD8 also, and it's a good solution. Next one is gonna get a little bit more complex. So what we are gonna do here is, as you can see, we are using many tables here. We have users table, wish list table, product table, alike product table, and products table. So what we are gonna do here is we are gonna look at user ID 1, and we are gonna start from the users table, and we are gonna go to the products table by using the wish list, which is gonna give me all the wish list of user ID 1. But I'm not gonna stop there, and I'm gonna actually start from the product table and go to product table again by using the like product. So I'm gonna get the wish list of this user ID 1. Also, I'm gonna get all the other products like all the wish list products. So with 4 line of code here, I can do that complex query. As you can see, Anna wished Kindle Fire HD8 and iPad 3. But also I have Kindle Fire 7 and iPad 2 in my store. So I can actually suggest that to my users in the same time. So that's great. As you can see, this is the match clause here, and you can run the same thing by using and or statements. It's gonna create the same query and the same results. Alright, so that was graph database tables. Now let's continue our adventure with new features. Next one I have here for you is machine learning. Machine learning is really popular lately, and everybody wants to learn about it. And SQL Server actually started to, I guess, use the machine learning with 2016 version. In 2016 version, Microsoft add the R services, R scripts to the SQL Server, and they call the machine learning R services then. And this was available only in Windows version. Then 2017 came, Microsoft changed the service name from R services to machine learning because they add a whole new language, Python. And this version was still available only in Windows. Then 2019 came up and Microsoft had another language, Java, on top of that. They kept the same name for the service, machine learning, but this time, this version, the machine learning, is available now in Windows version and the Linux version. Now, probably you're going to ask that, okay, those make sense, but what about those faces here? Why are they getting mad or upset? Well, those are our DBAs. Our DBAs are not happy with this because, well, they have worries. The first worry is now they are saying, okay, I know T-SQL, but I don't know R, I don't know Python, I don't know Java. How am I going to debug this? The second thing, those scripts, first of all, I don't know how to debug them. Second of all, I have absolutely no idea what they do in my SQL Server machine because they run actually in the same server. So I was one of those developers who asked my DBA to enable, I still had 2016, enable the R services. And I got declined, which is fine, because my DBA actually had a good reason. His reason was there was no way for me to actually monitor this. So you might just run this crazy script here, which I don't even know what it says, what it does. And on top of that, none of my monitoring systems can monitor what is really happening in the backend. And that's very acceptable. So after that, actually, I just started to kind of investigate this and try to figure out, what is available there. First of all, I don't know if any third-party applications are supporting this right now. They might. I don't know. I'm not here to sell any products. What I know and what I found is those links that I have here are from the GitHub of Microsoft SQL Server team, and they have some custom reports. Those are SSRS reports, and you can get them for free. And I think that 2017 one works for 2019. All you have to do is add them to the custom reports under the SSMS. And you will have some simple information about what is really happening with machine learning scripts. As you can see, they are not perfect, but that's a good starting point, and it might give you some peace to at least enable those features for your developers so they can kind of play with it and figure out how they can use it. Now, let's jump into our demo and let's fire up our SSMS again. What I'm going to show you here is right now is how to run machine learning script in SQL Server. So what I'm gonna do here is I have one very simple R script and I'm gonna run that. To do that, first of all, you want to be sure that R services or machine learning is installed and is enabled and is configured. To configure, you just need to run this statement here, and let me be sure that it's running on my machine. So when I run that, as you can see, it's running, it's 1. So to run any kind of script in SQL Server, actually all of them runs the same way. You have to execute this store procedure, and this store procedure accepts a couple of parameters. So the first parameter here is the language. Since my is R script, I'm passing R here. If you are going to run Python or Java, you can pass Python or Java here. This is the script that SQL Server is going to run. So as you can see, it's pretty simple. If you don't know R, what all it does is it's accepting some data, and then it's just sum the numbers up and returns it. So this is the data that I am sending to our script, which is, let's run that here. As you can see, it's pretty simple. I have a bunch of names and numbers. So really my R script is gonna do is just sum all these numbers up and return it. And by using the with sets, I can actually control what R script is gonna return. So in my case, I'm gonna return a column name total, and I want the type is gonna be integer. So when I run this, the first time it might take a little bit longer because it needs to fire some of the services, but as you can see, it returned a column name total as an integer, and it just added all the numbers up and returned to me. So this calculation actually happened in R script in the machine learning side. It's really that easy. Okay, it sounds easy, but you still need to know like what this thing does. So really, you might need to learn R, Python, or Java to be able to kind of really understand what's really happening here. All right, now let's continue. Next one is JSON. So JSON data type is not really popular by DBAs, but it's very popular by devs. Everything is in JSON right now in websites. So JSON functions are introduced in SQL Server 2016. The problem with that JSON functions and JSON type is, well, Microsoft did not really came up with a data type for JSON. Like for example, we have XML and we have an XML data type. For JSON, we have nothing. To make things worse, Microsoft suggested that if you have a JSON object, you should use varchar max for the JSON types. Well, that itself out there made the big red flag for each DBAs, which I don't really blame. So that's what the problem is. But what you need to know is you really don't need to use varchar max or varchar max. If your JSON object is smaller, you can use varchar 100 or varchar 1000, right? Nothing is stopping you. So without knowing that details, you might just say that there's no way I'm putting JSON in my database. So without going any more details, let's see what are actually the functions here. So there are a bunch of functions that you can use with JSON object, and is JSON, JSON value, JSON query, JSON modify, OpenJSON, and ForJSON are the, I believe, the only ones. And you can do all kind of stuff with this. So rather than explaining them to you, I will actually show them what they do. So let's go back our SSMS and let's look at what they can do for us. Now, what I'm going to do here is I'm going to use the Whitebird importers database. So you can just download that from the Microsoft SQL Server site. And here I'm just getting one JSON object here. So I'm looking at the invoices, and this is the invoice ID, and there's a JSON document here. So first of all, I'm going to show you what is JSON can do. Since there is no JSON data type, if you put the data in a varchar 100, well, you can really easily put any kind of string in that. So you want to be sure that whatever you are putting out there, if you're expecting JSON, you want to be sure that there's a JSON, valid JSON document in it. So is JSON just tests if this document is a JSON or not. So this is really good for constraints. So you can add the constraints, and that will be great if you will. So if your user will try to actually add not a JSON object, it will throw an error. JSON value here is it returns the value of whatever you are looking for. In here, I am looking the same invoice ID 100, and I am looking the value of the delivered when. So if you run that, the data is going to come as string. The very big thing you need to know about JSON documents. JSON documents do not have that much data types, and they do not have date time. So this comes in really string object. This is a big kind of topic we can always, talk about for hours, but that's something you should know. In JSON documents, there are not that much data types, and everything comes up usually in string or numeric. So JSON query. JSON query, you just query your JSON document here, and really it just returns the data in JSON object. If you run that, as you can see in our events, it looks like it's an array, and under array we have a bunch of events. The data comes back as JSON document. Next one is JSON modify. By using that, you can just modify your JSON documents. So in here, what I'm really doing here is I'm returning received by, and I'm changing it to SQL bits. So if you run that, I'm going to select that statement, and SQL bits is going to be somewhere here. But in this one, we did not really update the state, update the database. We just select it and just change it before we update it. If you really want to update it, you can run an update statement on it. So in here, really, I'm just actually really updating it this time. And as you can see, I'm saying delivery date should be a JSON modify. This is going to return a JSON document to this column. So if I run that, received by is going to change to SQL bits. And if I want to see if it's really changed, I can use the JSON value to get the value of this received by. And it is SQL bits. So that is great. The next one, if you wanna, just like XML, you can return your data in JSON document. So in here, for example, if you look at that, I am picking a bunch of columns, and I want to actually return this as JSON. If I do that, as you can see, everything comes up as JSON. That is very, very powerful if it's in really good hands of dev. Because what this can do is this can get rid of all the ORM your web application can have. If you return your data as JSON, and if you are using .NET or any kind of application, they should know, or it should be very easy for application to map what is coming up from the database, and all the classes in C# or whatever, the mapping is going to be perfectly matched, and you might not even need to ORM anymore. So that's a big topic which I'm not going to go in deep right now. We don't really have that much time left. So let's go. Next one I'm going to cover here is memory optimized tables. Memory optimized tables are, they have been out there with SQL Server for a long time. And we have two types of tables. The first one is durable tables. Durable tables are, the data is actually stored in disk and memory, and they are much faster than file tables because the data is going to actually come from the memory, but we are still going to need the file system because, whenever data is changed, you still need to go back to disk and update, insert, or delete it. Non-durable tables are very interesting. The data actually stays in memory only, and it doesn't even touch the disk. That makes them even faster than durable tables. And since we don't need any file system, you might just say that, okay, then if we don't have the file system, what's going to happen to the data when SQL Server goes down? Well, you lose it. And you might say that, well, then why do I need a table like that? Is my first answer for you will be caching the data. And caching the data can be really important for devs, and it can make things really, really, really fast. Now, well, also we have some different type of store procedures, natively compiled store procedures. Those are only for memory tables. And whenever you actually create a store procedure as natively compiled, what SQL Server actually does is it just creates a machine code from this store procedure and it puts in the memory. Then you are really gonna not need the query execution engine because your data is in the memory. Your program which grabs the data is in the memory. So really things are gonna get really, really, really fast because you are not gonna even need to compile the store procedure anymore because it's already compiled and it's in the memory. And the only problem with that is some of the T-SQL comments are not, supported by the memory tables yet. So you might have some issues with that, and all the store procedures becomes DLL files, and they are staying in this folder here. And that folder, whenever SQL Server gets come back from the restart or any kind of crash, then actually SQL Server compiles them again and puts them back in the memory. So in SQL Server 2017, there were a bunch of new updates for memory tables, and those were JSON support, cross-apply, computed columns, and there was no index limit. There are some more T-SQL statements added to memory tables like top and bind and case support. So that was SQL Server 2017 was great for devs for sure because there were many features. The trick here is when you try to combine some of those, you end up with really, really interesting things, especially when you have the JSON support, computed column, and no index limit in memory tables. That almost give you like one of the really powerful cache servers. To explain that to you, I'm actually going to jump in and show you what we can do with those options. So let's go back to the SSMS here. And let's look at what we can do here. So I always compare with Redis, and Redis is a cache system. There's a key and value. You must know the key to get the value, and usual value is JSON object. So what I'm doing here is I'm going to try to create some kind of system like that. So I have a summaries table. I have my ID. It's a primary key. So if I know the ID, it's always going to be easy to find what I'm looking for very fast. My summary is going to be, well, I'm going to make it varchar max, and I'm going to put JSON object in it. I don't have to do that. I can make this varchar 1000, as I said before. And I'm going to have a driver ID. As you can see, I'm going to make this one computed column. And this computed column is going to come from actually this summary object for a JSON object, and I'm going to get the driver ID from it. And it's going to be persisted, so it's always going to be there. So I don't need to go back and run this again and again. On top of that, I'm going to throw an index on it. So this is a very interesting thing we are going to do here. Let's try this first. So I create my table named summaries. The first thing I'm going to do, I'm going to add a constraint here because I want to be sure that whatever I inserted in the summary should be a JSON object. So first I'm going to do that. Then I'm going to put some JSON documents in this. Now I think this is going to add like 70,000, let's say 71,000 JSON documents in it in memory right now. If I know the ID, it really doesn't matter what type of table it is, it's going to be fast. I'm hitting index, it's fast. Now, if I try to run a JSON value, so look, this one, the Redis cannot do this. You must know the key in Redis to get that data. But in here, I don't know the key. I am actually going to JSON document to look for data. So when I run that, this itself is very powerful. Looks like it took some time, and this is from memory. And that kind of worries me. Let me see what happened. Oh, this is bad. It's a table scan. That's not good. What can I do here is, well, guess what? I have actually here an index, but my index is an integer, not a varchar. So I'm guessing If I change this to an integer and run the same thing, I'm hoping to hit to an index. Am I correct? Well, it was much faster. Oh yeah, there you go. I hit an index. So I'm in a memory and I'm hitting an index. But this signature of this is matching perfectly my computed column. So rather than actually running this, I should be able to call by driver ID. And when I do that, I'm gonna hit the same index. And as you can see, I'm hitting the index here. So, and also I can run the varchar here too. I will still hit that index. So this is great. And I can cache all kind of stuff here, and I can keep them here. I don't need to hit the real tables, and I can get my data here. And if I lose it, I really don't care in my side. So I like it. Next one I'm going to cover is temporal tables. I use them a lot in my job, and they make my life very easy when I need to audit my data, when I need to use trending, or if I truncate my data, hopefully not, I can recover my data very easily. And this is great, especially like if you work in like hospital or something, you know, a lot of patients comes in and probably take the same labs. Let's say the sugar level again, maybe every 2 weeks, 3 weeks they take. Guess what? If your table is a temporal table, you will easily create a trend for this patient. That's a good example, I guess. So how does it do it? So we have a real-time table, it's a regular table, and if you will make that a temporal table, what actually SQL Server does is it uses the same schema and creates a history table. And each time we are getting an update, delete, merge, or any changes to the real-time table, it just grabs this data, the data before it change, and puts them in the history table. So you have the newest data in the real-time table, and the old data in the history table. And this actually came in 2016, and there was one problem with this. And the problem was, in 2017, they actually fixed that, is the retention problem. So if you make one of your busiest table a temporal table, things can get really large very easy. And also, you might have a retention period, like, you know, your business might say that after 2 years, I don't care about this data. If you have 2016, that's going to be your problem to kind of go and delete this data from the historical data, historical tables. In 2017, they add a new parameter here, and if you actually add that here, as you can see, I'm creating an employees table here, and I'm saying after 2 years, SQL Server will start to actually delete that data from history for you. So that is a great addition. Now, let's look at a quick demo here. And let's see our management studio, temporal tables. As you can see, this is just the same example. All you have to really do here is you have to create a start and end date. It must be date time 2. And we are saying we are using these two date time 2s here, and we are turning it on, and this is the name of the history table we are going to use. So when you use that, all it's going to create this table and create the history table. So we are ready to go. In 2017, as I said before, there is this option. So after 2 years, the data is going to get deleted by SQL Server automatically. Now we have bunch of functions here for temporal tables. For example, I'm using the whiteboard importers here. This is the people table. I'm just looking how my data was, and I'm using as of. So how was my data in this date? Or I can say that this is the contained in, those are the 2 days. How was my data then? As you can see, it gives all the data, how it changed in those 2 days. What about between those 2 dates? Looks like my data changed. So as you can see, it's very easy to create trend here. And you can say the from and to, my data is getting large, or you can use the all, which is going to give all the data, how it changed from all the time. So this is great. Now, Our last one is the cluster column store indexes. Cluster column store indexes are great, and they compress and index your tables, and so that makes the data smaller. And also, whenever you use them, it doesn't store. I mean, it doesn't index by row, but it indexed by the columns. So if your select statement says, let's say you use only 2 columns, and then it's going to have the column elimination, and it's going to pick only the columns that it needs. You need to be careful when you are using them because it doesn't support all the data types, for example, the binary ones, and they are not really for OLTP. So if you are looking for a specific role, you still need your role store indexes. Here's a quick example. So as you can see, in the left side we have a summaries table, in the right side we have another summaries table, and one of them is using the column store, the other one doesn't. And when we do this and put some data in it, I'm adding 3.5 million rows here, and as you can see, the size of the data is really significantly low for summaries column store. And also, if I try to run some really weird query which has aggregation, group by, I'm using JSON values, I'm using casting, and a lot of stuff is going on here. Guess what? So when we run this, here's the average numbers we end up with. The regular one really averages 39 seconds to run this for 3.5 million JSON objects. This one is for 11 seconds. So that's a significant number, and it can make your life very easy. I kind of compare this with Cosmos DB structure, really. So this is really a Cosmos DB locally you can use a SQL Server for. All right, well, it's 45 minutes and I did it. And thank you for joining me today. And as I said before, you can follow me in any of those platforms, and you can ask me any questions if you will have. And also, please don't forget to fill out and the forms that you might have. And thank you again. Thank you for joining me today. I enjoyed it. I hope everybody learned something new today. Thank you.